Assalamualaikum. Very good day to MECR 0013 Cryptography. Another new video, another new chapter. This time it will be chapter 7. But before we move on to chapter 7, let me share the slides. So in chapter 5, you have learned about what are the components that made up a symmetric key cryptography, right? So do you remember? We need to have substitution, permutation, S box, P box, XOR, split and combine, circular shift, right? So there are circular shift. Wait, how many did I say? 6 or 5? Five. Swap. So once again, P box, S box, XOR, swap, circular shift, and split and combine. There are 6, right? So now it's our turn to learn about what are the techniques. Yeah, what are the techniques that we can call a symmetric key. All right. So when not initially, yeah. We are in the second standard already. Yeah, standard means standard that is adopted worldwide. Yeah. First one, yeah, was DES. I'm sure you have heard DES, Data Encryption Standard here. Yeah, Data Encryption Standard DES, which is a symmetric key block cipher published by NIST, yeah, in the US, National Institute of Standards and Technology. So it first started in 1973, yeah, a proposal by IBM, and then they call it Lucifer, and then finally we accept it as what we call DES, and we have been using it, yeah, as the standard, de facto standard, but yeah. Oh, before but. So DES is a block cipher. Yeah. DES is a block cipher. So symmetric block cipher. We're focusing on symmetric block cipher. So the input is you have 64-bit plain text. How many characters is that? 64 divided by 8. One character is 8 bits. So 8 characters. Yeah. So if you have a long email, you have to break it down into 8 characters by 8 characters. Put it in one block. So 64-bit plain text, yeah, 8 characters, and inside here is the DES cipher where you use DES, yeah, how DES works, and then you will produce 64-bit ciphertext. Okay, and the key used inside here with the plain text, you have to manipulate it either using P box, X box, swap, yeah, all those 6 techniques component. You will have to do it with a 56-bit key. All right, so you don't actually have 64-bit plain text and 56-bit key, 64-bit key. They are different size. So when you want to decrypt from the ciphertext, all you do is reverse engineering. Yeah, you do a reverse cipher. The same technique in DES, but you go from, instead of top down, you go bottom up. Right? So this is the general structure of DES. So you do have P box. Yeah. So first we have the initial permutation. So the P box is here, right? The component, one of the components. And then there are 16 rounds. Okay. So each round you have to do a manipulation. Yeah, maybe S box, swap. They do have swap. They do have split and combine in DES. All right. You do the same thing for 16 rounds. And before you produce the ciphertext, you have one final permutation. All right. And then the key, since you have 16 rounds, you don't use the 56-bit cipher key for all the 16 round. No, you have to generate different keys, 16 different keys. So each key for each round. From the original 56-bit, you produce a 48-bit round keys. So round one from the original plain text of the 6 characters, right? 8 characters. 8 times 8, 64. Yeah, 8 characters. Yeah, 64 bit. And then you go down to the initial permutation, and then you enter the round one. You will have to manipulate it with do some mathematics, yeah, logical expression, P box, S box, so on, with the 48-bit round key. Okay. So what is inside the round? Yeah, they are repeated for 16 times. So in each round, this is what it looks like for DES. Yeah, in each round. So your original 64-bit of plain text, first you split. Remember, split and combine. So you split it first into left 32 bits and right 32 bits. Okay, and the right half, you do expansion permutation, P box, expansion P box, right? Expansion, and then expansion P box, and then you have another component, you XOR it with the key. Yeah, with the key, you XOR it with the key, the first round key, and then you do an S box, right? Substitution, S box, and then you do another permutation, and then finally you XOR it with the left side. Yeah, and then there's a swap. Where is the swap? The right side here. Yeah, automatically you send it to the left. Yeah, and the left is used in the final XOR, and then it becomes right. Yeah. So this is the key. This is the left side is how we do the round, the first round. This is the key, how we produce the key. So out of our 56 original key, this is the round key. We shift. Yeah, remember? We have circular shift. So we do the shift on the both half. Yeah, one is left shift. We do left shift. And then we do some permutation. Okay. And then we get the key. All right. So this is in general how DES works. DES really use all the components of the symmetric block cipher that I taught you in module 5, chapter 5. However, DES is in 2005. Yeah, DES was withdrawn. Yeah, about almost 20 years ago, 18 years ago. Yeah, because it no longer provides the security that is needed to protect federal government information. Yeah, mostly because the keys are short. 56 bits is quite short. Yeah, it's not enough. People can easily break it. So from DES, we have triple DES. Yeah, derived from DES and introduced in 1998. So now we are actually using triple DES. However, yeah, even triple DES has been officially decommissioned in 2018, and this year it will be prohibited. We can't use it beyond 2023. This year is the last year we can use triple DES. Because why? DES and triple DES is now replaced by advanced encryption standard. Yeah, so from now we will use advanced encryption standard. However, I'm not going to teach you the actual AES because it has many rounds, 16 rounds, and then the plain text is 128 bits. A key, it's very complicated to be taught in one session of class or two session of class. Yeah. But good news is we will try to help you understand through a technique that is a mini version of AES. Yeah. So let's try to understand AES through Mini-AES. So Mini-AES was developed by a lecturer in Swinburne, Sarawak, yeah, from Cawangan, Sarawak. All right. So it has all the same parameters as AES, yeah. However, they are significantly reduced, yeah, so that we are able to do it by hand, manually, while even though it is significantly reduced, but we are still preserving the original structure. Yeah, so that we hope that not undergraduate student, even master students, first time having learning cryptography, can grasp the principle behind how AES work. All right. So this is Mini-AES structure. Just like DES just now. How does DES works? We have plain text, and then we have many round. Yeah, many round, and then each round there's a key, isn't it? Plain text, and then finally it will produce ciphertext. Yeah, same thing. The difference is that in here previously it was DES. Now in the round technique here, we use AES. All right. And then another difference is that how long is the plain text? There's a difference in the length of the plain text. There's a difference in the length of the key. There's a difference how many rounds for each for an AES. All right. So this is the general design of Mini-AES encryption cipher. Just for you, we are going to just learn 2 rounds only. Originally, AES has, if I'm not mistaken, 10, 12, and 14. Yeah, so we won't have time to finish until 14 rounds. So there's only 2 rounds. Yeah, just like even DES has a SDES, simple DES also. Yeah, so simple DES is also 2 rounds. DES has 10 rounds. Simple DES is 2 rounds. AES has 10, 12, 14 rounds. If I'm not mistaken, we'll confirm it later. Mini-AES has 2 rounds. All right. And for simplification, the plain text is only 16 bits. Okay. And then the cipher key, all right, each round must have its own cipher round key, and the round key comes from a original cipher key of 16 bits. So easy, 16-bit cipher key, 16-bit plain text. From the 16-bit keys, since we have 2 rounds, we are going to produce 2 different keys, K1 and K2. And then you ask, wait, there's K0. K0 is the same as the original key. All right, so K0 is the original key, and then you expand it to produce K1 and K2. So use K1 for round 1, use K2 for round 2, and then finally you will produce a 16-bit ciphertext. So in here there is a component, yeah, a component for to make up the Mini-AES. All right, symmetric key, symmetric round key symmetric key cipher. All right, so what is inside here? What is inside here? All right, so inside here there are 2 rounds that we have to repeat. Inside round 1, these are the component that we use. First is nibble sub, yeah, substitution as box. So in here, so okay, we call it nibble sub because instead of using 8 bits, we are exchanging, yeah, substitution, only 4 bits. So 1 nibble is 4 bits. So every 4 bits we substitute it. All right. So 8 bits is 1 byte. Right? 8 bits is 1 byte. 4 bits is 1 nibble. We call it nibble. So 2 nibbles, 1 byte. All right. So a computer science term here. So we nibble sub every 4 bits. So we're going to do substitution first. And then from nibble sub, there's a component called shift row. Yeah, component called shift row. And then there's another component called MixColumn. So this, we call it round 1. Okay, just like this, there's an initial round that is not considered inside there. So first, we have our plain text. We have to XOR. Yeah, this is XOR symbol, XOR. So we have to XOR with the original key. And then for first round, nibble sub. Yeah, so produce B, and then into shift row, produce C. C, we do MixColumn, produce D. D, we finally we XOR with our first key. So that is round 1. And then round 2, they are the same except they only have the first 2 components. They only have nibble sub, shift row. Luckily, you don't have MixColumn because later on you'll see that nibble sub is easy, substitution. Shift row is easy. You just, split it. You just swap. This is swap actually. Yeah, shift row is swap. Nibble sub is substitute S box, swap. But MixColumn has slightly, I'm going to be honest with you. Students always have problem with MixColumn because it's an actual mathematics. You have to divide, you have plus, yeah. But the good news is you only have to do it once in round 1. All right. And you end with, in round 2, with XOR of K2. Then finally you get the ciphertext. All right. So don't worry. Yeah. In the exam, you can bring your crypt sheet. You just need to understand how it's done. Understand it so that you won't get confused during exam what to use, where to use it. Okay. So the components are here. S box, we call it nibble sub, 4 bit. Shift row is swap. Yeah. I'm gonna swap the nibble. And then we have MixColumn and we have XOR. All right. So 2 rounds only. All right. The original AES use, let us check the original AES use how many? 128 if I'm not mistaken. Yes, yeah, the original AES use 128 bits. But in our Mini-AES with 2 rounds only, the plain text is only 16 bits. Yay! Clap, 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 clap. All right, can you imagine doing things with 128 bits? So only 16 bits. Alhamdulillah. All right. So out of the 16 bits, yeah, we split them into 4 nibbles. Remember, 1 nibble is 4 bit. So 4 nibbles, 4 times 4, 16. Yeah. So 1 nibble, second nibble, third nibble, fourth nibble. So we call it plain text, right? So P0, P1, P2, P3, and we represent it as a matrix, 2 rows by 2 columns. Yeah, but we arrange it this way. Okay, not row by row, column by column. So P0, P1, P2, P3. P0, P1, P2, P3. So arrange it. Yeah. Nibble. P0 4 bit, P1 4 bit, P2 4 bit, P3 4 bits. So total 16 bits plain text. Okay, let me try to make you understand. So we write email. Dear who? Dear Messi. I don't know. Or maybe Benzema. Dear Messi. Okay. Blah, 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 blah. XO, XO. All right. So because this is a special letter for Messi, you don't want other people to read it. You want to encrypt it. You want to make it secret so that nobody can understand, can read the letter and understand it except Messi, because you're going to give the key to Messi so Messi can decrypt it. So in order for you to encrypt it so that nobody can understand it, yeah, you need to encrypt. So you're going to encrypt using AES. So what you do is first, all this, every letter, you change it to binary numbers. Yeah, 8 bits, 8 bits, 8 bits. So there's maybe D is 1 0 1 1 0 0 0 1, for example, and then E has 8 bits. Yeah, ASCII code. So now what you do is you're going to put 16 bits. Remember, this is a block cipher. So you cannot do, it's not a stream cipher, right? It is a block cipher, which means 2 letters is 16 bits. So this is going to be put DE to into AES. Yeah, and then ER, oops, you cannot see it, another. And then ME, okay, so first we're going to do DE, 16 bits. So DE is going to be set here, for example, Dear Messi. So first we put in plain text DE, change it into 16-bit binary numbers. Yeah, 16-bit binary numbers. All right, and then we're going to produce one ciphertext. So DE, first XOR with KO, and then nibble sub, shifro, MixColumn, key addition, and then second round, you get a ciphertext. Maybe the ciphertext is this. Once you've done that, one block, second block. What is second block? Yellow, isn't it just now? Pen, yellow. AR, dear, yes. AR. Do the same thing. Okay, 0, first round, second round, get the ciphertext. So the ciphertext for AR is maybe MT. And then different color. So the first color is actually red, isn't it? So DE. Yeah. It produce this. AR produce MT. And then ME. Messy, yeah. ME, same, one block. You do first round, second round, it will produce IE. So this is the one, and then you finish everything lah. Yeah? How many blocks do you have? If you have a long email, a long letter, it will be a long ciphertext also. This is the one that Messi gets. And Messi won't even understand it unless you give Messi the keys. You need to give Messi the same key here. Messi needs to have this key. If Messi doesn't have this key, he cannot decrypt it. Yeah? So I hope you understand what we're doing right now. We are encrypting, and we have to encrypt block by block. Each block is 16 bits, 2 character. For Mini-AES, we try to make it smaller so you can understand easier. Okay? All right. So let's start with the first one first. The first one, DE. Okay? So change. So D is here. E is maybe 0, 1, 1, 1, 0, 1, 0, 0. So P0 is 1, 0, 1, 1. This one. P1 is down here, 0, 0, 0, 1. Example. 0, 1, 1 is here P2, 0, 1, 1, 1. And then 0, 1, 0, 0 is P3. You have to arrange it that way. Got it? Okay. So now we have the plain text. Yeah. we have the plain text ready. We have the plain text ready, P0, P1, P2, P3. So before we go into round 1 and round 0, there's a pre-round here. We call it pre-round. What we have to do, we have to XOR it with K0. Yeah. Since we are looking at the keys, so next we want to do is, let's create the Mini-AES key schedule. Yeah, let's create the schedule, meaning we want to create K0. K0 is the original one. We want to create K1 and K2. Okay, we want to create K1 and K2. So the easy thing about Mini-AES is that everything is 16-bit. Plain text is 16-bit. Original key is cipher key is 16-bit. The round key is also 16-bit. Okay, so we have the 16-bit secret key first. That is the original one, K0. And then we're going to use that to create 2 extra key, K1 and K2. Okay, so K0, round 0. So K0 is the original key. So the original key. All right, same thing also. We always split it into nibble. So if just now for the plain text P0, P1, P2, P3. For the K is the key also K0, K1, K2, K3. Okay? Yeah, got that? And then we use W instead, yeah? We call it word, W, word. So word 0, word 1, word 2, word 3 is the original K0, K1, K2, K3. All right? So it actually, you just ignore this. K0 is the original key. Right. From the K0, we are going to, from the K0, we are going to create K1. Okay. There's a formula. There's a pattern actually. I'll show you. Okay. So since K0 is word 0, word 1, word 2, word 3. So for K1, it will be word 4, word 5, word 6, and word 7. Yeah, W4 until W7. Okay. The pattern is here. It's very easy. W4 is you bring W0 all down here, and then you leave the first one first, the W4 first, but then W4 you put it down here, 4, 5, 6. Yeah, 4, 5, 6. All right. But I told you, no need to memorize. You can look at your crib sheet. Copy this formula. All right. So the first one, to get W4, it is the original W0 XOR with, we're going to use nibble sub also in our key schedule. We do nibble sub of W3. Yeah, we bring, that's why W3 is here. W4, we go down here. That's a pattern. Yeah, like I said, it's puzzle and pattern in cryptography. Okay. Another value that you see here is archon. Archon is round constant. Yeah. So for each, for the first nibble in each key, in K1, it is W4. In K2, it is W8. We have, in K1, we use archon 1. In K2, we XOR with archon 2. And since it's a constant value, archon 1 is 0001. Archon 2 is, what is 0001? 1 in decimal. And Archon 2, 2 in decimal, which is in binary, it is 0010. Yeah, in binary, it is 0010. So we're starting to use binary numbers now. Okay. All right. So W4 is ni. Okay, excuse me. So let's do an actual example, yeah, of a real number. All right. Okay, so suppose we have a secret key, the original key. This is K0. Okay, I put it up here. K0, K1, K2, K3. And remember the pattern? Nah, right? It is this way. So K0 correct, K1 correct, K2 correct, K3. Okay, we established that. And these are also the same as W0, W1, W2, W3. So we have our key for the pre-round, K0. Yeah, so this is K0, same as the original cipher key, 16-bit. Now let's do the calculation for W4. Where's W5? Oh, W5, W6, and W7. What happened to W5? All right. So just plug it in to the formula. So W0 is this. I write it down again. W0, W1, W2. I'm doing this slowly, yeah? You follow me together. W3. So W0 is 1110. All right. This is Archon 1. Yeah? Archon 1 from the formula. It is always this value. All right. Next, we need to do nibble sub. So S box of W3. So we have to nibble sub this. All right. Okay. I'm going to KIV first. This nibble sub. Yeah, I'm going to KIV first. Because we're going to use nibble sub a lot in the encryption. So let's just, I'm going to tell you. Then we'll come back. You have to come back and confirm the value. So to do the after substitution of 000, you will get 1111. Okay, so XOR. So the student know how to do XOR? Okay, do it one by one. Yeah, don't have to do it all at once. So let's first do the first one. So remember, do you remember the table for XOR? Why? So 0, 0, 0, 1, 1, 0, 1, 0, 1. So this is XY, yeah? XY. If they are the same, they are 0. If they are different, input is different, they are 1. Okay, let's do. Same. Start from LSB, from the right-hand side. LSB, least significant bit. 0, 0, same, 0. 0, 1, different, 1. 1, 1, 0. 1, 1, 0. Okay, you have, and then you XOR with the Archon here. You've done this. You've done this. Then you're going to XOR it with the third nibble. 0, 0, 0, 1. Always start from LSB. 0, 1, different, 1. 1, 0, different, 1. Same, same. Look, sama. Yeah, they are the same. That's how you do XOR. Don't forget this. At the end of this course, you'll know this by heart. Okay, so you have you need the W4 because W5 is, this is WK. Let's do let's write down the pattern. W0, this is W1, W2, W3. And then this W4 is here. That's why you need to settle W4 first. W4, W5, W6. So you will XOR W1 here, 0, 0, 1, 0, with W4, the one you get from the previous calculation. So it is very important that you get your W4 correct. If W4 is wrong, W5 will be wrong. W5 is needed for W6. W6 will be wrong. W6 is needed for W7. W7 will be wrong. So be careful. Yeah, be careful. The effect is avalanche, right? So You'll calculate W5, you calculate W6, you'll calculate W7. So what is your K1? K1 is you combine W4, W5, W6, W7. Put it together, 16 bits. All right? And then you do the same thing for K2. So K2, you need W7. Yeah, you need W7. And don't forget RCon for round 2. The round constant, this is round 2. The round constant is also decimal 2. Convert it into binary. It is 0010. So you get W8, W9, W10, W11. Yeah, so we get, this is K2. Okay, try to check my answer here. Are they correct? All right. If they are not, or you are confused, discussion, we'll discuss this. Okay, so we have our K0, which we got it from the original one. We do the calculation, we got K1. We do another calculation, we got K2. Right, they are berkait, yeah? So you better be careful starting from W4. If W4 is wrong, everything is wrong. So now we have our plain text. Yeah, so okay, this is a question. This is a question. We have our plain text, and then we also have our K0, the original, that we have already also derived K1 and K2. So I'm going to stop here. We will continue with the next video on how to do the encryption technique. All right? Okay.